Every AI prompt you send is processed by clusters of GPU servers that can draw over 100 kilowatts per rack. That's not the cloud, it's a machine. And in 2026, Britain is drawing 2.5% of its electricity to run it, heading for 4 times that by 2030. Let's talk about the giant nobody's looking at. Section 1, the scale of the boom. Let me put a number on this because the number is genuinely a bit mad. As of mid-2026, the UK data center market is worth somewhere between 12 and 17 billion pounds. And it's not sitting still, it's expanding fast. The IT load capacity right now is about 4.19 gigawatts, with strong double-digit growth on the way. By 2030, the announced pipeline could push that past 10 gigawatts, with some forecasts pointing toward 12 to 15 gigawatts by 2031. And that's what puts the UK in the position of being Europe's leading data center hub. Now here's the part that surprises people. Where are they all? Because it's not spread evenly. Greater London and the Southeast absolutely dominate over 80% of the national supply. London alone hosts somewhere north of 150 facilities. You've got the big clusters, Slough, which in some reports is the largest concentration in all of Europe, London Docklands. The Heathrow and M4 corridor, sites tucked across Hertfordshire, Essex and Acton. Then after London, it's Manchester and the Northwest, the next biggest, with hyperscale activity growing fast. Wales is in the game too. Newport and Cardiff with a serious pipeline, including Vantage Data Centers campuses. And then there's the new wave, Scotland, the Northeast, Newcastle and Blyth in Northumberland, where there are major plans worth around 10 billion pounds from Blackstone and QTS Teesside. The Midlands, Birmingham, Leeds, Oxfordshire sitting inside the new AI growth zones, and behind all of it, the giants, AWS, Microsoft, Google. Operators like Vertus, Equinix, Arc, Global Switch, billions committed, region by region. This isn't a tech story anymore, it's a map of Britain being quietly redrawn. So why now? Why the sudden gold rush? Section 2, why AI is the driver, one word. AI. AI workloads are completely transforming this sector and the government has gone all in. You've got the AI Opportunities Action Plan, you've got AI growth zones designed to speed up exactly this kind of build. And this is a big one, data centers have now been given critical national infrastructure status. Same category we use for the things the country genuinely cannot function without. That status is a signal. It says this is national priority, build faster. And here's the technical shift driving it. AI doesn't sip power the way old computing did. It demands high density racks. We are talking 40 to 150 kilowatts and beyond per rack. These facilities have to handle 2 jobs at once, training the models and then the surging never-ending demand of inference. That's the bit that answers your questions millions of times a second. That's why the designs are changing. Modular builds, liquid cooling, it's becoming the standard, not the exception. But all that power, all that density, it comes from somewhere. And that's where the story turns. Section 3, the power and water problem. Here's the tension at the heart of all of this. Right now, data centers consume about 2.5% of the UK's entire electricity supply. Doesn't sound like much, except the projection is a potential 4-fold increase by 2030. And that's landing at the exact same moment the whole country is trying to electrify everything else. Cars, heating, industry. Something has to give, and it already is. Grid connection delays in London can run to years. So developers are voting with their feet and going to regions where they can actually plug in. Now the part most people never think about. Water. You'd assume in cool rainy Britain, water's a non-issue. And to be fair, a lot of facilities are smart about it. Free air cooling, adiabatic systems. Over half report as largely waterless. But AI changes the maths. The denser the racks, the more evaporative cooling you need. So follow the numbers. UK data centers currently use an estimated 14 million liters of water a day. If we hit our AI targets, that could triple to around 42 million liters a day by 2030. A single mid-sized site might drink hundreds of millions of liters a year. A hyperscale campus, far more, and the equivalent of thousands of households. And it doesn't stop there. Generating the electricity to run these places uses water too. That's the indirect footprint. Government reports are now flagging AI's water demand as a genuine national security question. They are calling for early planning in water-stressed areas. And the southeast, where most of the centers are, is exactly that. So communities and regulators are starting to look hard at every new project. What does this do to our local water? This is the friction, power and water versus ambition. Section 4, the sustainability fixes. But this is the hopeful turn the industry isn't ignoring. 2026 is genuinely a year of clever solutions. Start with cooling. The shift is toward liquid direct-to-chip and immersion systems. And in closed loops, these can cut water use by up to 90 to 95%. That's not a small tweak. That's a different way of building. And operators are leaning into water efficiency and reclaimed sources. Then power. Renewables through PPAs, power purchase agreements are standard now. But the really interesting move is nuclear. There's growing serious interest in small modular reactors, SMRs, for reliable low carbon power lined up directly with those AI growth zones. Picture a small reactor sitting next to a data campus, powering AI around the clock. That's not science fiction anymore. That's a 2026 conversation. And underneath it all, the discipline metrics, PUE and WUE, power and water usage effectiveness. The scorecards operators live by, modular builds for speed, and waste heat reuse, taking the heat these buildings throw off and actually doing something with it. There's policy behind it too, pushing for sustainable growth with operators targeting climate neutral goals by 2030. On-site generation, edge computing, retrofitting the old legacy sites. These are the moves that decide whether expansion and net zero can live in the same sentence. So where does that leave us? Honestly, at a balance point. On one side, the pressures are real. Grid constraints, rising costs, planning scrutiny, talent shortages. We don't have enough people who know how to build and run these. And the sheer resource demand. Projects are getting delayed. Inquiries are digging into the sustainability impact. But on the other side, the opportunity is enormous. Jobs, economic growth, genuine AI leadership on the world stage. And the whole thing comes down to one question. Can we build fast and without being reckless with power and water? Because data centers in 2026 are the beating heart of Britain's digital and AI future. As this spreads out from the London hotspots to regional growth zones across the country, it has to evolve to be not just powerful but efficient, sustainable, and actually welcome in the communities it lands in. The choices made today, right now, shape the UK's infrastructure and its net zero goals for decades, not years, decades. So here's what I'll leave you with. Next time you ask AI something, anything, just remember there's a windowless building somewhere off a motorway doing the work, pulling power, sipping water, carrying the future on its back. The real question isn't whether we build them. We will, it's whether we build them right. So I want to hear from you. Where do you land? Do we race ahead and power the AI revolution, or do we slow down and protect our power and our water first? Tell me in the comments. I read them. And if you want more of the story behind the AI everyone's using but nobody's looking at, you know what to do. That giant of the M4 isn't going anywhere. The only question is how big it gets.